Welcome to the party. Mr. Sutton here, bringing you the Pre-Cal Honors 4-4 Part 2 homework solutions on laws of logarithms. For number 8, we're trying to merge all of this stuff into a single logarithm. To start it off, I'm going to use the pop-in rule on this 2. We could pop in the 3 on everything, but we don't need to go that far. So this will be log base b of m squared. Next, I'm going to merge all the stuff inside this parentheses. I'm actually going to wait until the very end to deal with this 1/3. So moving the stuff inside together, since we have subtraction here, we can do m squared divided by n. And then this other subtraction, whatever you divide a fraction by ends up in the denominator. So there's going to be this p moving downstairs to be with the n inside this fraction. Now, this 1/3, we have to deal with it at this point. We can use the pop-in rule to raise all of this to the 1/3 power inside. And you're actually done if you want to be at this point. Optionally, you could turn this into the cube root inside the logarithm, and it looks a little fancier, but it's the same thing. For number 9, we're trying to merge all these ln's together using our laws of logarithms. So there's no pop-in rule to do in the beginning. We're just going to go straight to merging things. Since we're adding these logarithms, this first expression and the second expression will be multiplied together. And since we're subtracting this log, this a squared times b is all going to end up in a denominator. So when the dust settles, these first two terms are in the numerator, this last one in the denominator. At this point, we're going to simplify as much as we can. So I'll just take care of the numerator first. We have a to the negative third times a to the negative 2. That's going to come out to a to the negative 5th. And then this will be b to the third in the numerator. Dividing now, this will be a to the negative 7 if I subtract those exponents, times b squared. And to get rid of that negative exponent, we can move the a downstairs to become a to the positive 7. So when the dust settles, ln of b squared over a to the 7th is our final answer. For number 3, we want to turn this expression into a single logarithm or rational number. So first step on these, we want to use the pop-in rule to get those coefficients inside the logs. So this will be log of x to the 8th plus log of y to the 5th minus log of z. Next, addition is going to turn into multiplication when we merge the logs together, and subtraction is going to turn into division. So we've got log of x squared, or x to the 8th rather, times y to the 5th, and that's all going to be divided by z inside one big logarithm. For number 4, we're trying to merge these all into one big log. So when we do this, since these are being added, we have to multiply the arguments of the logarithms together. So we could call this log of 2 times 3 times 4, which is really just log of 24. And since there's no whole number where you can raise 10 to something to get 24, no rational number, we're just going to have to call it a day on this. For number 5, we're trying to express this as a single log or rational number. So there's a lot of ways to do this problem. One way, just kind of if you're not looking at exactly what's inside these logs, is you could start with the pop-in rule and make this log base 3 of 3 to the 3rd. And then, if you're combining these two logs together, since the logs are being added, you can multiply the stuff inside. So this would be log base 3 of 3 times 3 to the 3rd, 3 times 27, which is really log base 3 of 81. But now hold on a sec. 81 is a power of 3. 3 to the what would give us 81? Well, 3 to the 4th. So we can simplify this further just down to 4. Now, a slightly faster way of doing this, in the very beginning, if you looked at what was actually in here, log base 3 of 3, well, what do I have to raise 3 to get 3? Well, 1. So this is just 1. This is 3 times 1, which is just 3. 1 plus 3 also gives us 4. For number 6, we're trying to turn this into a single log or rational number. So we'll start with the pop-in rule on this 3. We'll make this minus log of 20 to the 3rd. Then to move these logs together, we have to turn addition into multiplication of the numbers inside, and subtraction turns into division. So we've really got log of, parentheses, 4 times 2 divided by, well, 20 to the third is 8,000. We can just do that now. 4 times 2 is 8. 8 divided by 8,000 is 0.001, or 1/1000th. Since this is log base 10, we can actually simplify this further. 10 to the negative third would give us this. So that's actually our final answer. For number 11, we need to simplify e to this expression that has an ln in it. Before we can cancel the e and the ln, we have to pop in that negative 15 as an exponent. So this will be e to the ln of x to the negative 15. Now the e and the ln can cancel. And instead of writing x to the negative 15, I'm going to write 1 over x to the 15th, just to get rid of that negative exponent. For number 12, this is a little bit tricky because we have subtraction going on inside an exponent. So to really wrap your mind around this one, you have to ask yourself, when do we subtract exponents? Well, one time we subtract exponents is if we divide a base by the same kind of base, and then we just subtract their exponents to deal with that. So you could rewrite this as e to the 8th divided by e to the ln of 5. Because if you were to try to merge these back together, you'd be like, oh, division, I have to subtract the exponents. So let's actually simplify this now. E to the 8th we can't do much with, but ln of 5, e to the ln of 5, that's going to cancel the e and the ln, leaving us with just 5. So this is then just e to the 8th divided by 5. For this problem, they're asking me to simplify this expression, which they mean don't have all the stuff inside the exponent here. So I'm going to start by splitting this exponent up. Since I'm adding these two things in the exponents, I can unmultiply this into two different expressions with base e. So I can write this as e to the negative 1/7 ln of x times e to the 6th. Because if I multiply things with the same base, I'm just adding the exponents like we are up here. So I'm just unadding these into different e expressions. All right, for my next step, I'm going to do a little bit to clean up this first expression. So I can start by popping this negative 1/7 in as an exponent inside my logarithm here. So this will be ln of x to the negative 1/7 inside there. And then I know that e and ln cancel out because they're the same base. So that just leaves x to the negative 1/7 times e to the 6th. And if I want to be really fancy, I can simplify this expression to be e to the 6th over, this will be the 7th root of x in our denominator. For number 10, we have 10 to this 1/3 log of 125. In order to simplify this further, we first have to get the logarithm in the exponent to not have any coefficients. So we need to pop in this 1/3. So now that I've done that, a few things I'm going to do on the next step. 125 to the 1/3, well, that's actually the cube root of 125. And now that I have 10 to log base 10, the 10 and the log can cancel. So this is really the cube root of 125 we're dealing with now, and that cube root is just going to come out to 5.